Hello, welcome to the Labredoor Dark's project presentation. Have you ever wondered why astronauts need to grow plants on the International Space Station? In 1983, at Space Shuttle Columbia, with the Space Transportation System 9 program, plant biologists studied 4-day-old sunflower seedlings. The release of sunflower hypocotyls under microgravity. They grew plants in the ground in small pots and kept them in aluminum nodules. Thus, the program of growing plants outside the world first started. The main purpose of these studies is to make plants more useful for space missions. For this purpose, plants are an integral part of long-term bioregenerative life support systems and, in this context, should be the main components of efforts to establish larger-scale controlled ecosystems on extraterrestrial surfaces. Now, I want to tell you what is the bioregenerative life support system. The bioregenerative life support system is actually an artificial ecosystem. Initial studies of bioregenerative life support systems focused on algae systems. However, recent research has focused on growing more traditional crops using hydroponics to eliminate water and nutrient stress, so plants were chosen as the building block of this system. Plants recycle human waste and provide food to humans, while humans recycle plants' waste and provide them with nutrients. These two creatures owe their place in the ecosystems to each other through a complementary relationship, and so they support their life in the ecosystem in a cycle. In the bioregenerative life support system, the most important function of plants is to provide oxygen to humans. Since the plants are grown under artificial light at the International Space Station, the required photon cannot reach the plants at full capacity. Therefore, a decrease is observed in the efficacy of oxygen production, which is the most vital function of plants for humans. To increase this productivity, we as genetic engineers plan to add various genetic mutations to plants to better adapt to purple light. We consider using the CRISPR-Cas9 method as the most effective technique to achieve this. With this method, we aim to maximize the adaptation of Solanum tuberosum, potato, LSI1, the silicon uptake gene, to multiple stress conditions, radiation, extreme hot cold, metal toxicity, drought flooding, salinity, and oxygen release capacity by regulating the gene activity. Actually, the main purpose of this gene is to manage the silicon uptake mechanism. As we know, the silicon molecule increases plants' efficacy and tolerance ability against various stresses. Hence, in order to be sure, we are additionally planning to create a plant medium which includes orthosilicic acid. In conclusion, we are presenting a plant and its medium for space stations, long-term space missions, and perhaps for other planets in the future.